Hello guys, in this video I'm going to introduce you to this new project which is quite interesting. It is called as Replace Anything 3D. This is primarily a text guided 3D scene editing. Look at your screen, there is a park scene with a white plinth. On the left hand side on that plinth we have a statue, and then with the help of this model we are replacing that statue into a corgi dog on top of that plinth. The way it is happening is that on the left hand side we have inputs, and then this model is converting it into this corgi dog, which is a Welsh small breed dog. Anyway, if you look into this further, the model is quite interesting. Replace Anything 3D, and it is also called as RAM 3D in short, is from Meta. It is a text guided 3D scene editing framework allowing object replacement in multi view scenes for realistic integration, overcoming structural loss limitations. It also showcases effectiveness in various realistic scenes, and I will show you shortly, despite artifacts like the Janus multiface problems. If you don't know what Janus multiface problem is, then let me give you a very quick overview. So the Janus multiface problem refers to the complex challenges and dualities that arise when designing and implementing machine learning models. This use of Janus with its, and it's a metaphorical use, with its emphasis on two faces or dual aspects, highlights intrinsic conflicts and trade-offs encountered in machine learning. So it could be like bias versus variance trade-off, it could be interpretability versus accuracy trade-off. So that is what this model is trying to resolve. Okay, now there is also a future work in it, and that includes geometry appearance, disentanglement, and prompt debiasing to refine the scene editing. Now, if you look further into this model, this is how it works. So, on the left hand side, there is a statue input on that white plinth. From there, it removes the masked object and fill in the background. Then it inputs it into the RAM 3D. From there, the statue is erased, and then in parallel, the stage is replaced. And from there, it just combines both of them and then give you the in-painting LDM. Let me describe these terms a bit. So all in all, as you can see, input is being passed, then it is being edited by erasing the stuff and replacing the stage, and then it is combined, and then we have hypha loss, and then in painting LDM. Now hypha stands for hierarchical feature alignment, and this loss in machine learning is a specialized loss function designed to improve the alignment of features across different levels of a neural network, particularly in tasks involving hierarchical structure or multi-scale feature integration. It aims to enhance the model's ability to learn complex patterns by ensuring that the feature at various levels are effectively combined and aligned, leading to better performance in tasks such as image recognition, segmentation, and object detection. Hypha loss facilitates the coherent integration of features from multiple layers, improving the model's accuracy and efficiency. And then we have this in-painting LDM, which is receiving the input from composite form. In-painting LDM, or in-painting latent diffusion models in machine learning, they basically mean or refer to a technique for generating or reconstructing missing parts of images or videos using model based on concept of diffusion process in latent space. This approach leverages the power of diffusion model, which gradually converts random noise into structured patterns to in-paint or fill in gaps with content that is coherent with the surrounding image context. It is quite effective for tasks such as image restoration, object removal, and content creation, and it has been proven to offer high quality realistic results. Then at the end, it generates or trains a new NeRF using edited image scene, as you can see here. Now, NeRF stand for neural radiance fields, and it refers to a framework for rendering 3D scenes from a set of sparse 2D images, and I have various other videos where I go into further detail. There are various other examples. For example, if you go to this example, You can simply move this slider to see how quickly and how realistically and seamlessly it transforms the object on top of that white plinth. And look at this one. Just keep an eye on this rabbit. It's gone. Amazing stuff. And it doesn't really impact anything else. In fact, if you see, there are shadows on the top surface of this plinth. When I move it, the shadows remain. And even when the rabbit is gone, the shadows replace it. So how realistic it makes it. Amazing. So this is the attention to the detail and in painting fill. And then there are various other examples on their website. You can see that things can be replaced and all that stuff. There you go. So really, hats off to these people who have done a fabulous work on this one. I couldn't find the code. I will keep my search on. If I could find the code, I'll try to install it locally and show you how exactly we can do it. Until then, share your thoughts in the comments. And if you like the content, please consider subscribing to the channel. And if you're already subscribed, then do me a favor and share it among your network. Thank you very much.